up in just a few moments.
Hello? Can you hear me? Can you hear me now?
You're good. Go ahead. I promise. Do it.
All right. Thank you so much for your patience. Welcome to Town Hall. We had no idea when we planned this event how excited people would be about it. We shouldn't have been surprised because we're especially excited about the Eclipse and about our Eclipse party that we're going to have at McPhee Park on August 21st. We're thrilled that Dr. Mark Littman is willing to come and share his expertise about eclipses with us, and I hope you'll be able to stick with us. He's going to talk for about 40 minutes and do questions and answers after he's finished speaking. I wanted to introduce him a little bit. I'm Wendy Smith. I'm the PR and marketing coordinator for the town of Farragut. Dr. Mark Littman holds 2 endowed professorships in journalism and electronic media at the University of Tennessee, where he teaches science writing for the general public. Before joining UT in 1991, he directed a large planetarium in Salt Lake City for 18 years and taught astronomy at the University of Utah and Loyola University. He's helped lead eclipse expeditions to Canada, Hawaii, Bolivia, Aruba, and Turkey. And Dr. Littman, where will you be during this eclipse?
Douglas, Wyoming.
Wyoming. His most recent books are Totality, The Great American Eclipses of 2017 and 2024, Eclipse, The Sun Revealed, a Planetarium Star Program, and Eclipse 2017, a book for children ages 8 to 14. He's the author of 4 other books about astronomy that have won 4 national awards, and is the author and producer of 35 planetarium programs. He has copies of Totality, The Great American Eclipses of 2017 and 24 out in the lobby. You can pick up a copy afterwards, and you can also place an order for the children's book. So thank you for coming. Welcome, Dr. Littman.
Thank you very much, Wendy Smith. Thanks to Lauren Cox. Thanks to all of you for being here. T-minus 40 days and counting. This is a very special time, and obviously you all know that already. Let me take you back in time. By the way, maybe we can turn off these lights up here, and I'll begin to show you some slides as well. Let me take you back in time to 1918, before the days of television. It was even before the first radio station went on the air. And I'm taking you out to Kansas, the middle of Kansas, a farm family, the Ansagers. Florence Ansager was 13 years old. She was playing with her brother and sisters outdoors, a nice, clear summer afternoon, and all of a sudden, it began to get dark, and then darker still. And her mother called for all the kids to come into the house immediately. The father came running in from the cornfields, and they all huddled together, knowing that the world was coming to an end. That was the eclipse of 1918. I know, and I don't know what to do about it.
Your body back, can you turn it?
Oh, maybe if I just move the mic a little bit?
Or you can move to the podium, depending on...
Okay, well, that's another possibility. Should we try that?
You just can't.
Okay, I hope I won't stand in people's way here. Let me see if I can
That sounds good.
move it to a little better position. Is that any better? Is that coming through? Okay, I'm sorry, folks. Didn't know what was quite happening there. Well, let me stroll out of people's way of looking at things here for just a moment, and let's take a look at what will happen here in Farragut at about 1:04 in the afternoon on August 21st. You will see the moon beginning to edge in front of the sun. And over a period of about an hour, 15 minutes, more and more of the sun will be vanishing. It looks a lot like somebody eating a moon pie. And you'll see a little bit later that that's exactly how a number of ancient folks looked at it, as some kind of celestial monster taking bites out of the sun. In the last 15 minutes before the eclipse becomes total here in Farragut and to places southwest and south of here, you will begin to notice some startling changes happening gradually and then faster and faster. You'll notice, for instance, that the sky will still be blue, but it will become a kind of steely gray blue, probably a color you've never seen before. The grass will become kind of a steely gray green color. You'll notice animals becoming more and more nervous. If you were out in farmland, the cows would march back to the barn on their own, or they'd lie down and start bellowing and go to sleep. Chickens will go to roost. Birds will squawk, fly back to their nests. Nighttime animals may begin to emerge. It's a very confusing time even for human beings, as that first story said. So this is a kind of idea what will be happening. The next picture is not perfect for what I'm trying to discuss, but it'll give you some idea. And that is, as the eclipse is approaching totality, off in the west, there'll be a mound of darkness that will continue to grow bigger and bigger on the horizon, like a giant thunderstorm. That's the shadow of the moon approaching at about 1,500 miles an hour. And then it will rush upon you and swallow you up. In the last few seconds before the eclipse becomes total, you'll have the diamond ring effect, where only a sliver of the sun is still visible. The diamond ring effect. And as that happens, the corona, the outer atmosphere of the sun, begins to emerge, something you'll see on no other day except during a total eclipse. And you may notice also reddish, they're better even than this picture can show, fluorescent red prominences, magnetically controlled gaseous storms in the atmosphere of the sun. You can see one at about 11:30 in this picture, bigger than the Earth. Here are more of them, and you can also see that now the diamond ring has passed, and the moon is so close to covering the entire sun that only the sunlight coming to you through the valleys between the mountains on the moon reaches you. It breaks up into dots, and those are called Bailey's beads, after the man who called Europe's attention to them back in 1836. More prominences on the sun as it's just about to be a total eclipse. Every time you see a total eclipse, it will be different. The corona will be different. The prominences will be different. it's a different event. And this is what you can never fully anticipate. The corona now, you can see the prominences about 11:30 and 5:30, but the outer atmosphere of the sun extends outward for millions of miles. It extends actually all the way to the earth and beyond, so that we are traveling in our orbit around the sun. We're actually swimming along through the sun's outer atmosphere. The corona is just spectacularly beautiful. And from time to time, you will see, say, enhancements in the corona. Different eclipse, different corona. And look at about the 2 o'clock position, you can see that there's been a coronal mass ejection. The sun has had an explosion of its atmosphere so that the gases go rushing off into space at millions of miles an hour. Billions of tons of material headed outward into space. And as that material and the radiation encounters the Earth's magnetic field divides it, it moves towards the poles, it excites the upper atmosphere of the Earth, and you have displays of the aurora. One of the things that's startling is that you're so used to the sky being dominated by the sun. You know, obviously so bright that you don't look at it with your eyes alone, with your unaided eyes. Oops, creating more problems for myself now. So, what happens now, let me move the mic just a little bit, because what happens, and you can get a kind of sense of it here, what happens is that it suddenly looks like there is a hole in the sky, as if you can look right through that hole to outer space. And you're actually, of course, looking at the moon, and the moon hasn't got any sunlight on it. It's dark, and it's completely hiding the face of the sun. Let me tell you a story about that, too. You can see why, if you've never seen a total eclipse before, even if you have, this never ceases to take you by surprise. So let me take you back now to 1970. In New York City, there was a 14-year-old boy named Glenn Snyder. He was an amateur astronomer, belonged to an amateur astronomy club. The eclipse was not going to be total in New York City, so he got his parents' permission to allow him to join other astronomy club members, and they were going to take a bus south to North Carolina to observe the eclipse there. He was prepared. He had 3 cameras slung over his shoulders. He had a tripod. He had motion picture camera. He had a telescope. He had binoculars. He had solar filters. He had a checklist for everything that he was going to do leading up to the total eclipse of the sun and during the 2 minutes 54 seconds that eclipse was going to provide of totality. He was prepared. He got to the football field of what is now East Carolina University. The football stands weren't as big as they are now. He climbed, he got everything set up perfectly. Everything aligned, all was well. He went up the steps of the stands to look off to the west to see that thunderstorm-like darkness building in the west. No lightning, no thunder, just the shadow of the moon. He saw it, watched as it got bigger and darker. He ran down the steps, got to his cameras, everything was ready. He glanced up in the sky to make sure what exactly was happening. The diamond ring effect occurred. The corona began to emerge. And he sat there, stood there, stunned. He couldn't take his eyes off of it. He couldn't start his cameras. He couldn't look through the telescope, didn't pick up the binoculars. He just stared for 2 minutes, 54 seconds. And when the eclipse was ending, the period of totality, he said to himself, for the rest of my life, no matter where on earth a total eclipse occurs, I will not miss it. Glenn Snyder is now, Dr. Glenn Snyder, he's a University of Arizona astronomer. He's a Hubble Space Telescope principal investigator, and this year will be his 34th total eclipse of the sun. That's what this does to you, and I will hope for you this one and many more. Here's many of the pictures that I'm showing you are taken by my co-author, Fred Espinette, who's really a master at eclipse photography. This is a picture he took in Zambia in 2001. But you know what he would say to you at this very moment? He'd say to you, this is nothing compared to the event. The sky is darker than you see it here. You see the twilight all the way around the horizon more vividly than here. You see stars visible and planets visible in the sky. It's altogether better than any picture can show. And it's a lot better than any words I can bring you on the subject. Looking back mythologically, people long ago were very concerned about the sun vanishing in the middle of the day. If it stayed gone, it was doom for society. Here's how the Chinese saw it. As a celestial dragon that would leap out from behind a cloud or from beyond the horizon, grab the sun and begin to chew on it. And that's why the Chinese would always yell, scream, bang on pots and pans, bang on drums, shoot fireworks into the air to scare the dragon away. And it always worked. Many societies have these myths. This is one from India. It's about a demon named Rahu. Here you see the demon. The demons gave birth to the gods. The gods discovered immortality. They had immortality because they could drink the nectar of immortality, Amrita. And Rahu and the other demons wanted badly to be immortal themselves. So one day, Rahu crashed one of the parties of the gods, and he sidled over to the urn that held the nectar of immortality, and he poured himself a drink, and he was just about to take a sip when the sun and moon at the party pointed out Rahu to the chief of gods, Vishnu. Vishnu grabbed his discus, threw his discus, it severed the neck of Rahu. Rahu's body fell to the ground, but he had begun to drink the Amrita, so his head was immortal, and his head was very angry. So it went rushing off into the sky, chasing the sun and moon. And from time to time, it catches up with the sun and moon. Here you see it happening. And he begins to take bites out of the sun to no avail. Because as you can see, he swallows the sun, but it comes right out his neck and puts itself back together. That was the myth from India. It wasn't all myths by ancient peoples, though. They were so concerned, many of them, that they tried to find ways of understanding and predicting when these eclipses would happen. Perhaps the earliest, most successful people were the Babylonians, who were collecting and writing down their observations of eclipses on clay tablets using their cuneiform writing. And here you see a fragment of one of those tablets with information about eclipses. They collected those for hundreds of years. After about 150 years, about 600 BCE, they had enough of those tablets so that some great genius or geniuses began to realize that eclipses take place in intervals. For instance, if you took this eclipse this year, 2017, and if you added 18 years and 11 days to it, you would accurately predict another total eclipse of the sun. If you subtracted 18 years, 11 days from this eclipse, you would have another total eclipse of the sun. So that's what they realized they could do. Eclipses occur, and even total eclipses occur more often than not. But take any eclipse of the sun and moon and add that multiple of years and days, and you will have an eclipse. That's what the Babylonians discovered. They discovered that kind of cycle. Really quite amazing, especially when you consider that they couldn't see all of the eclipses. They would see more than half of the lunar eclipses that they would predict, but they would see only a tiny fraction of the solar eclipses. All credit to the Babylonians. The Chinese were busy at it also from about 779 BCE. I think that's about the right date for the first eclipse record on what are called oracle bones, animal bones or turtle shells that were used to record these events. It took the Chinese until a little over 2,000 years ago until they also recognized patterns and could predict eclipses. And even so, neither the Babylonians nor the Chinese initially quite understood how these eclipses occurred. Among other people to do remarkable eclipse predictions were the Maya, about 500 CE. Here you see some pages from the Dresden Codex. It's one of only 4 Maya books that still remain. And it gives you some remarkable information. For instance, I hope this will work. Let's see. There, can you see that right there? That's the glyph for the sun. And then right there it's daytime, and here is darkness. So the sun is going from light to dark because it's being eaten by this feathered serpent, Quetzalcoatl. And you say, well, that's very pleasant, seems kind of mythological and so forth. But look here, leading up to it, these are Maya numbers, the precise day count that leads to that eclipse. And you can see that here's another eclipse, date, the count, more eclipses, and so forth. So the Maya were also keeping track of the days and could predict these events. People are often interested in whether Stonehenge could predict eclipses. I don't know anyone in the field who thinks for sure that Stonehenge was doing that. But let me show you some alignments that are very interesting indeed, I think. How many people here have been to Stonehenge? Ha! Wonderful, wonderful. We are standing right in the middle of Stonehenge right now, And, oh, sorry, well, that shows you what happens if I stumble over these things. We're looking out over the heel stone, many yards away. It's 35 tons of stone right there. This Stonehenge began its building more than 5,000 years ago, 3,100 BCE. The heel stone was in position by at least 2600 BCE. And in fact, there wasn't one heel stone, there were two. So that right between the two on the horizon, that is precisely where the sun would rise on the longest day of the year, the beginning of summer. So what the people who built Stonehenge had created was a remarkable calendar at very least. Here's Stonehenge seen from the air. You can see the, sorry guys. Oh, here we go. You can see the giant trilithons here. They are 50-ton uprights. The heel stone is off in this direction. So we're looking down on Stonehenge, what remains of it. Here's an artist's view of Stonehenge. And what I call your attention to are the two heel stones here. Here's where we were at the center of Stonehenge. This is what Stonehenge looked like probably about 2400 BCE. And what's, I think, particularly interesting are the so-called station stones. At the beginning, they were wooden posts, but by 2600 BCE, they were stones, big stones, set up in that pattern. And here's what they mean. You can see from the center of Stonehenge out over the heel stones, that marks the beginning of summer. And so do the line from this station stone to this, and that station stone to that. But from this station stone to that marks the position where the moon rises when it is farthest south of east. And this marks where the sun sets on the shortest day of the year. And this marks where the moon sets when it is farthest north of east. There are all kinds of other orientations which indicate that these people knew very precisely how the sun and moon were moving, or apparently moving in the sky. And you could depend on those motions. And the reason I mention that is because we're used to seeing the moon moving in our sky, waxing and waning, becoming a full moon, a declining, waning crescent moon, and so forth. You know that when the sun is rising, just about to rise, if it's full moon time, the moon is about to set. When the sun is setting and it's full moon, the full moon is rising. But over the days after full moon, you have the moon continuing in its orbit around the earth, and it's moving over to catch up with and pass by the sun's position in the sky. So if you were the people of Stonehenge, or if you were other ancient peoples, you could watch to see where the moon, the crescent moon, appeared on the eastern horizon just before the sun rose. And if the moon was very close to where the sun was rising, there was a good probability that the moon would go right in front of the sun and cause an eclipse. So we cannot say that Stonehenge could predict eclipses, but you can see that the people of Stonehenge were on the right track to be able to do that. We don't have eclipses of the sun and moon every month because the moon's orbit around the earth is not in the same plane as the Earth's orbit around the sun. You see in this diagram how the moon's orbit is tilted 5 degrees to the Earth's orbit. So that, for instance, right here, when the sunlight hits the moon, the shadow would fall below the Earth. Over on this side, when the sunlight hits the moon, the shadow of the moon falls above the Earth. No eclipse. So twice a year, there is the necessity of the moon actually casting its shadow on the Earth. So it happens at least twice a year, but more than a third of the time, those are just partial eclipses. Nowhere can you see it as total. And about a third of the time, they're what are called annular eclipses, where the moon is a little too far away from the Earth to completely block out the disk of the sun. So you have a ring of sunlight around the moon. So it's not a total eclipse. It's a special kind of partial eclipse called an annular eclipse. We'll look at those in just a bit too. So less than 30% of the time do we have a total eclipse. So we have a total eclipse about every year and a half. And we mustn't waste it. This is a newspaper article from 1976, Melbourne, Australia. Total eclipse of the sun. What's their reaction? Lock up the kids. Can't have them going outside staring at the sun and blinding themselves. Plus the adults would do the same, of course. And here's the newspaper. The only safe way to watch today's eclipse? On television. Now, no offense to television, and they'll do a good job. What you see on television, what you see in pictures, can't touch what you yourselves are going to experience. I think in Australia in 1976, the only person I know of who got it right in terms of educating the public, and I may be mistaking this again, was a cartoonist. And he drew this cartoon, shows two guys about to be executed up against the wall, and they're blindfolded, and one is saying to the other, luckily we're blindfolded, we won't harm our eyes looking at the eclipse. But of course, as you already know, it's very easy to protect yourself during a partial eclipse of the sun. You have solar filters. Often they're made into cardboard frames like this, and I can't see a thing through it because they're 10,000 times, takes 10,000 times the light. So in other words, it's good for blocking most of the sun's light. So you can watch carefully with this. And these are what you'd use, or something very much like it, not sunglasses. You'd use these through all the partial phases of the eclipse. But of course, once the eclipse becomes total, the very bright disk of the sun has vanished. And so you take these off. If you don't, you won't see a thing. So you can watch the eclipse in totality, the total phases of the eclipse, with no filters at all. You mustn't have a filter. And then, when the sun begins to emerge from behind the moon, back on with the filters again. An easy way to... How many of you have blinded yourself by going out on an ordinary day and staring at the sun? Nobody thinks to do that. Children don't do that. Now, you ask a child, now, if I could block off half the sun, would you stare at it? No, it's clearly too bright. If I block off 3/4 of it, if I block off 7/8 of it, still too bright. And that's the whole trick. You keep looking at the sun through a solar filter, a special kind of solar filter, until the eclipse becomes total. Then, no filters at all. Another picture by Fred Espinette showing all the partial phases and the total phase. Commercial. This is the book that Fred and I wrote, and here's a children's book just out. On the right is the front cover, and on the left is the back cover. And this is a children's book for kids ages 8 to 14. Enough commercial. This is a nice annular eclipse. You don't get to see the corona. You can see the bright disk of the sun shining all the way around, except that the moon is just edging its way to full annularity, and you're getting Baily's beads. Actually, it's beginning to move away. You're getting Baily's beads. Can you see all those? Like diamonds in a necklace. It's just very beautiful. That is what impressed a man named Aubrey. Oh gosh, I'll come back to that. So these are Baily's beads, and he saw this and called Europe's attention to it in 1836. In 1842, there was going to be another eclipse of the sun. This was going to be a total eclipse of the sun, visible in Spain and Italy. No one in that period in the scientific community in Europe had ever seen a total eclipse before. So they were expecting to see Baily's beads. And instead, they saw the diamond ring effect. Baily's beads, yes indeed. And then the corona. And they were stunned. And from that point on, every time there was a total eclipse, astronomers and then the general public were going all over the world to see this event. And it's from those studies that we finally understood how the sun works, how the sun shines. For instance, in Greek days, up here at the top, that was what the Greeks thought, or at least Anaxagoras, about 2,500 years ago. He thought the sun was shining because it was spinning. Now, how spinning made it shine, we don't know. We have only a tiny fragment of his work. But that's what was thought. Then later, people said, well, it's burning like a lump of coal. But that didn't hold up for very long because they calculated, even with the sun being 865,000 miles in diameter, it wouldn't take too long for that coal to burn out, only a few thousands of years. So the next idea was that the sun was shining by the impact of meteors falling, asteroids falling into the sun. But as hard as they tried, people could never observe anything like that happening to give enough brightness to explain the sun. So the next idea, too soon for Einstein. Here we have the Helmholtz contraction theory. Helmholtz thought the sun by gravity was shrinking. And in doing so, it was like you're rubbing your hands together. And you know how you can make them warm by doing that. So the sun was shining by the friction of all its particles as it shrank. And that was not a bad idea. If the sun shrank only by the length of a football field a year, it would create all of the energy that we have. But that would allow the sun to last only for a few tens of millions of years. And by that time, people were beginning to realize that it was billions of years old. Enter Einstein. 1905 publishes the theory of special relativity. And in it is that wonderful formula, E equals mc squared. The c squared, the speed of light, squared, big number, but it's a constant, so we can ignore it for a second. The real significance, of course, is that E equals m, and that's something people had never thought of before. The idea that energy can be converted into mass, and mass can be converted into energy. Different scientists began to realize that you could explain how the sun shines by converting mass into energy. In fact, they calculated if the sun was made, and this is one of the other things they discovered by looking at eclipses, by looking at the atmosphere of the sun, they could study the atmosphere, realize that it was mostly hydrogen, therefore the sun had to be mostly hydrogen, and if you had abundant hydrogen and you squeezed it enough to raise its temperature to about 27 million degrees Fahrenheit, that you would have, say, 600 million tons of hydrogen converted into 596 million tons of helium every second, with the destruction of 4 million tons of mass. And that's how the sun shines. That's the reaction going on at the core of the sun. And 4 million tons of mass being lost, converted into energy every second, allows the sun to shine pretty much as it's shining now for the next 5 billion years. And it's already been shining for 4.6 billion years. So, thanks to Einstein. So the sun now had an explanation for how it shined. And the sun, as a reward, then turned around and proved Einstein's general theory of relativity in Einstein gave the world the general theory of relativity in 1916. And one of his predictions was that massive objects can bend light. Now we've seen light bend to make rainbows, and we've seen what prisms, like little drops of water, can do to bend light. But can a massive object bend light? Again, something people hadn't thought of before. So there's a cutaway of the sun. Now, here's what Arthur Eddington, who was really the leader in proposing that the sun was shining by nuclear fusion. Here's what he took from Einstein. If you have these two stars way, way away in space, their light is coming to you, straight line. And so you look back and from their light, you see them off in those positions. But if the sun were in that position, then the starlight that would be blocked, say, by the sun, some of the starlight would be passing in that direction, but as it went by the sun, it would be bent. So it would get to the earth, and you'd look back to see where that star was, and the star would look like it was there instead of there. And sorry for my trembling fingers. But I think you can see what kind of prediction that would be. But that's useless, of course, right? Because when the sun is in the sky right there, it's daytime, you can't see the stars. Except when, like August 21st. And here's the man who led one of the two expeditions from Britain in 1919. One went to Brazil, the other went to the island of Principe off the coast of Africa. And this is actually one of their pictures. And the little white lines that you see bracket stars that they were measuring. They had measured these stars at other times, so they knew exactly where they were in the sky relative to the rest of the star field. Would they move? Would they be displaced because the sun was in the way, because the sun's gravity had bent their light. And indeed, that was exactly the case. They announced it late in 1919. And it was then that Einstein became famous. He was noted by all the scientists at the time, but the public didn't know his name. After 1919, he was the most famous man in the world and remained that way for the rest of his life. So, here's what's coming to you on August 21st. As you know, we're sharing this eclipse with no other country. Kind of selfish of us. But we have been deprived in the mainland United States for 38 years, so it's our turn. The eclipse comes across the Pacific Ocean, touches no islands, and then it dives southeastwardly across the country, passes through Tennessee. Nashville is in the path of totality. Farragut, right where we're standing right now, gets 1 minute, 24.4 seconds of totality. And you can compute that, you can check it on maps and so forth, so you know exactly. If you actually go a little bit southwest or south of here, you can build your time in totality to 2 minutes, 2 minutes 30 seconds, or up to about 2 minutes 38 or 39 seconds. The maximum this eclipse lasts in southern Illinois is 2 minutes 40 seconds. So you get about all there is. And every second of totality is precious. It will happen so fast, it'll seem like just a few seconds has gone by. And then here is a map of our area with Knoxville here, as you can see. Stay on campus, stay in downtown Knoxville, get a 99% partial eclipse. And a partial eclipse is, a 99% partial eclipse is to a total eclipse like, imagine your favorite event to attend. Say it's Hamilton, or your favorite musical concert provider, or whatever you like the best. You've got perfect tickets, and you go to the theater, or you go to the auditorium, and you stand out in the lobby. You can sense that there's excitement, but you've missed the main event. And that's what's happening to downtown Knoxville. But I can think you're right about there. So you're a little bit inside the path of totality. Oak Ridge gets 7 seconds of totality. Not nearly enough. Got to push away a little bit south or southwestward. So let me tell you just one more thing about a total eclipse, then I'll go to questions, if that's right. Talk longer than you can possibly stand already. But one of the things that's interesting to me, and I hope you will do this too, watch the reaction of people. If the skies are nice and clear, you get to see a total eclipse. Watch the reaction of people when the eclipse becomes total. There's a gasp like you've never heard before. People just can't say it. They gasp. Then, when the eclipse is over and the sun is beginning to emerge from behind the moon, people will scream, they'll yell, they'll applaud. Imagine applauding for a natural event. But they do, and they cry. No matter how many times you've seen them. And the first thing that people will say is, when is the next one? Thank you so much, people. Okay, sure. Any questions? Yes, sir.
Athens, Tennessee is right on the center line.
Perfect.
You can also watch the progress by shining a mirror image on a wall. We did that in 1970 and watched could see about half of the eclipse that was going by. Just any shaped mirror, small, large, doesn't matter. You get the same semicircular image as it progresses.
Okay, the gentleman is saying that he, in 1970, used a mirror to reflect the sun's image against a wall and was able to watch the partial phases of the eclipse. You won't need that, of course, during the total phase of the eclipse, but the partial phases, very good. Yeah, let's, I'm sorry. Yes.
I'd like to know, is the flat area the better area to see? I'll be on a big hill with a flat area. What is you're talking about, the view of the darkness and then all this? So do I need a big glass fence to see?
It would be nice if you had a good, clear view of the western horizon and or the eastern horizon so you can see the shadow coming and going. But that's not absolutely essential. Just someplace you can be comfortable. Take a chair or a blanket if you're comfortable sitting on the ground. Take refreshments. It's kind of a tailgate event. That's right. That's right. So some people are going off to the mountains for the eclipse, but that's the risk. You said it exactly. The mountains build clouds. So oftentimes valleys have less clouds than the mountains. If that were the Rockies, which are very high, it's a notable effect. The Cumberlands give a small effect like that. Yes?
I've seen the aurora borealis many, many times because I live in northern Alaska. Is it possible to see the northern lights during the eclipse?
No.
I didn't think so.
No. It isn't that. I've seen the aurora when it's so bright that you could see it in twilight. But what you'll see during a total eclipse is a kind of twilight. Right. Bright enough, dark enough, so that you'll see 4 planets this time. Right. And some bright stars, but not the whole star field. Right. So no aurora.
Unless it were dark
Yeah. And we need to be further north to see the aurora better. But you know what? I've never heard anybody comment on it, but when the 2015 eclipse occurred north of the Arctic Circle, in the Faroe Islands, which were clouded out, and Svalbard, it might have been possible if there was an aurora going on at the time. Doesn't happen, as you know, all the time.
A lot of it's about solar flares.
Yeah, there are a lot of solar flares, a lot of coronal mass ejections, but we have to be the target of that outstreaming of material. Yes, ma'am.
How can you protect your eyes from, to see that eclipse?
The only time you need to protect your eyes are during the partial phases of the eclipse, which about an hour and 15 minutes before it becomes total. Then it'll be total for a minute or 2 or 2.5, depending on where you are. And then it'll go back to being a partial eclipse. And that's when you put back on your solar filters, your eclipse glasses.
Where do you obtain those?
These you can get, I think, that some of the stores in town, maybe Walmart. Does anybody know who's selling them in town? You can get them on eBay. That's very true. I saw them on Amazon. In fact, I saw them on Amazon advertised for, one was advertising them for 87 cents each. One was advertising them for $1 each. Carolina Biological Supplies. So they're not very expensive. Yes, sir.
Less than $2 at Mass General.
Oh, thank you. Less than $2 at Mass General. Yes.
It is a cloudy day like we've had for the past 3 weeks.
It won't be as spectacular. No, not anywhere close. You won't see the corona. You won't see the prominences. You won't see Bailey's beads. You'll just notice that it gets dark in the middle of the day, and then the darkness sweeps away. You'll notice the animals getting very fretful about it, but it's heartbreaking to be clouded out. It just is. Well, for instance, Glenn Snyder, that I mentioned to you before, the 14-year-old boy, he was in Melbourne, Australia, trying to see that total eclipse in 1976. He jumped in the car the night before, or the day before, and drove about 500 miles to get to a better position because Melbourne was going to be clouded out, and saw the eclipse from a hillside with 1,000 cows grazing who were trumpeting in anxiety, and then laid down and went to sleep. Yes.
Are you going out west to minimize why are you going out west?
Yeah, that's right. I'm responsible for a group of about 50, and I had to make a choice in terms of trying to optimize the weather the best I can. And you know, for all of that, you may well have better weather here than we get. But that's what eclipse chasers do. They look for the best chance. I'll tell you how awkward it is. For the eclipse in 2015, north of the Arctic Circle, the Faroe Islands had a 20% chance of seeing the total eclipse. Svalbard had a 10% eclipse. Faroe Islands were clouded out. Svalbard saw it perfectly. I mean, just that's what happens. And people have come from all over the earth. Quick story about that. When I was trying to make reservations, hotel reservations to begin with, I had first looked at Rexburg, Idaho, and Idaho Falls, thinking that I could take my eclipse group to Yellowstone as well, and to Grand Tetons and so forth. But this was 3 years in advance. It was too late. The hotels were already rented out. 2 years earlier than that, to groups from China and Japan. That's what kind of event you're in for. And see, the fact that you're expressing, that you're noting that is, I think, the closest anybody can come to expressing how wonderful, how spectacular a total eclipse is. It's the stories, I think, that ultimately give you the best impression.
Dr. Lips,
yes.
We'll take 2 more questions.
Thank you very much. Okay, sir.
When's the next one?
Thank you very much. When is the next one was the question. Thank you. If you turn to 2018, you're out of luck. No eclipse, no total eclipse that year. 2019, you get to go to Chile and Argentina. 2020, believe it or not, weird thing, back to Chile and Argentina, but further south, Patagonia. 2021, Antarctica. There will be thousands of people going. Then in 2022, no total eclipse. 2023, the total eclipse nips the westernmost corner of Australia, just a tiny little peninsula, not much bigger than this room. A little bigger, but not much. And then it goes up through East Timor, now called Timor-Leste, and then through Borneo, where the chances of observation are about 0 because of clouds. So then, April 8th, 2024, the eclipse, a total eclipse comes back to the United States. It'll come to us by way of the Pacific Ocean, through Mexico, through Texas, up through southern Illinois, crossing the path of the 2017 eclipse, through Cleveland, through Buffalo, through northern Maine, out over Newfoundland. So April 8th, 2024, put it on your calendars. Go see it. One last question, back there. I'm sorry. Is it a good idea to take the dogs? You know, I'm fascinated by that, in that when I first had a part-time summer job at a planetarium, there was going to be a partial eclipse early in my tenure there. So I was answering the phone all the time, giving people advice about the partial eclipse, how to see it. And one woman, I'm sorry, this is not you, one woman called and said, "How do I protect my dog's eyes?" You know, do I have to put, she actually said, should I put my dog in the closet? Is it enough just to keep the dog indoors? How can I protect my dog's eyes? So, sure, your dog is going to, I'd be interested in how the dog behaves. There's actually a story about that, what happened. One person back in the 1800s, after people realized how exciting eclipses were, he wondered what the dog's reaction would be. So he kept food from the dog for a day or so. And then when the eclipse was turning total, just before it turned total, he gave the dog's favorite food to the dog, and the dog went after it, and then the diamond ring occurred, the corona appeared, and the dog dropped the meat and just was stunned and was looking around. And then, as soon as the eclipse was over, the dog went after that meat. So, what I'm going to ask of you is to please let me know what the dog's reaction is. This will be a good scientific event. And thank you, Ms. Smith. Thank you. Sure. Oh, yeah. Oh, sorry.